Hello everyone. In this video, I'm going to show you how to solve problems based on Beer-Lambert's law. See, Beer-Lambert's law, we can say the absorption is equal to epsilon Cl. So C is the concentration, L is the length of the medium, A is absorption. If absorption is given, if you are considering length of the medium is 1 centimeter for example, and we can able to analyze the concentration, right? So if any one of the parameters is given, the other one can be easily calculated. In other way, if the absorption is asked, by giving the percentage transmittance, it is also possible. We know that absorption or OD is equal to log of I naught by I. So what is I naught? I naught is intensity of incident light. Intensity of incident light considering a object which is kept in between the light path. Now when the light is passing through the object, the other way there is a detector. So the transmitted radiation will be detected by the detector. So this is I naught. Intensity of the incident light is I naught. The intensity of the transmitted light is I. So there will be absorbed radiation, IA, absorbed radiation. Let us consider I naught and I. I naught is the intensity of incident radiation. I is the intensity of transmitted radiation. So if we take this equation, this can be simplified as log 1 by T, which is equal to A, absorption. So if we consider this as a percentage, A is equal to log of overall 100% of the incident light is passing through an object, and what is a percentage transmittance then on the other side, if it is 100, right, percentage transmitted. So you can use this equation to calculate either percentage transmitted or absorption. Okay, if we know the absorption, percentage transmittance can be calculated. If we know the percentage transmittance, absorption can be calculated, right? Suppose if the absorption is given or the transmittance has been asked in the question. For example, consider this question. A solution which has the concentration 3 mg per liter, it absorbs, the OD value 25%. It absorbs 25% of the incident light. It means the incident light is 100%. The absorbed light is 25%. Right? They have not said, they have not mentioned about the transmitted light. They are mentioning about the absorbed light. In the UV radiation liquid state analysis, we will be always analyzing the transmitted light. This much amount of light transmitted, okay, that will be mentioned. But where the absorption will be mentioned, right? The absorption can be calculated from the value intensity of incident, the intensity of transmitted. Intensity of incident light minus intensity of transmitted light will give you the absorbed radiation, right? So this is intensity of absorbed light. Intensity of absorbed light, so it is 25% is equal to 100 intensity of incident radiation minus I, so that the I can be calculated as 75%. So intensity of transmitted light is 75%, right? This is how we can calculate. And let us consider this one, 3 mg per liter is a concentration, 25% is OD absorption, and then 1 centimeter is the thickness of the medium. Now the question is, calculate the intensity of transmitted light if the solution contains 6 mg per liter of substance. So now concentration differs. We know that the transmittance for this is 75%. If for 3 mg it is 75%, for 6 mg how much transmittance is the question. See, when the concentration increases, transmittance is going to be decreased according to Beer-Lambert's law, because absorption gets increased when the concentration increases. Okay, so we know 75% is the transmitted light here. Log of I naught by I is absorption. A is equal to epsilon Cl. So we can substitute this in this equation, so that you will get log I naught divided by I is equal to epsilon Cl, right? So what is log I naught? I naught is 1. right? 100% divided by, and transmitted light in the first case is 0.75, because 75% transmitted is equal to epsilon, because we don't know the epsilon value. Epsilon need to be calculated into what is the concentration in the first case, 3 mg per liter, into length of the medium is 1 centimeter. So epsilon can be calculated. If you simplify all this, you will get finally the value 0.042. Okay, so this value can be taken, and we need to calculate for 6 mg per liter, right? 6 mg per liter, this will be liter per mg per cm unit, liter per mg per cm unit, because epsilon we are calculating, log of 1 by 0.75 will be calculating here. So this is concentration, which is milligram per liter. This is concentration in centimeter. So this is unit of centimeter, this is milligram per liter. So you will be getting liter per milligram per centimeter unit for 6 mg per liter. Log I naught by I is equal to epsilon Cl. Now log of I naught is known 1 divided by I. So I need to be calculated here, right? Transmitted light is equal to epsilon value is known 0.042 into concentration is 6 mg per liter into length of the medium is 1. Now log 1 by I is equal to the value we can calculate, which can be 0.25, and then simplifying this will give you log 1 minus log I 0.25. Log 1 is 0, so minus log I is equal to 0.25. I is equal to anti-log of 0.25, that will give 0.562. This is what the transmittance. So converting this into percentage will give you 56.2 percentage. So see, this obeys the Beer-Lambert's law. 3 mg per liter, it absorbs, it transmits 75%, absorbs 25%, right? See, it transmits 75%, absorbs 25%. When the concentration increases to 6 mg per liter, it absorbs 56.2%, right? So from this we can understand the increasing concentration will actually increases the absorption of radiation at particular wavelength. Thank you.